Today on 9.7b, we are continuing our probability and mostly the concept of probability. So let's think about our situation, a specific situation. Let's talk about an ice cream shop. And we are in summertime at an ice cream shop, and we'll call it Sparkles, right? Sparkles ice cream. Oh. And let's say one day at Sparkles ice cream, they got 200 customers. And Sparkles ice cream, we'll say it is an artisanal ice cream place, and they only have 4 flavors. Of those 4 flavors, we have vanilla, chocolate, say raspberry, and birthday cake. As their flavors, or in this case, V, C, R, and B. And let's say of those raspberry, vanilla, chocolate, birthday cake, we had the following numbers out of the 200. Let's say chocolate is the main favorite. Out of the 200 customers, 100 customers got chocolate. Vanilla, we had about 74 of those get chocolate. So then we are left with raspberry and birthday cake. Birthday cake, not pretty popular. So we actually had 20 people got birthday cake, and only 6 people get raspberry. So now let's let's put all this in a pie chart. If I were to draw a pie chart, it'd probably look like this. This being chocolate here. Vanilla is pretty big. No, vanilla, and then this is very definitely not to scale, but we have the numbers already up here. Definitely not to scale at all. Say chocolate's this color, vanilla's this color, raspberry's that color, and birthday cake is that color. If I had to pick one of those customers at random, let's say if I went to that store at a random time during that day, and I picked a customer, what is the probability that the person that I find is going to be a vanilla person? Well, that is 74 out of 200, or as we need to reduce this. 74 out of 200, that's also 37 out of 100. So the probability is that 37 out of 100 that the person we run into is a vanilla person. Then another question we can ask, well, what is the probability that that person is not a vanilla person? We're like, well, what is the probability that, well, we know what it's if we pick a person to be a vanilla person, what if they're not a vanilla person? So then we take the difference between 200 and 74, that's 126 out of 200, and that probability right there, if we reduce that, it should be 63 over 100. So the probability is 63 out of 100 is not going to be a vanilla person. Let's take this chart again and let's think about what if we didn't know that it was 200 people. Let's say it was a different day. Numbers are still, the percentages are still the same. We still got the same amount of percentage, but we did not actually have 200 people. Let's say for vanilla, we want to know, instead of 200, we had a big booming day and we actually had 500 customers. So what we need to do is say, okay, we had 37 out of 100, or percentage, 37% of our customers were vanilla people. Well, so then to find out how many of those out of 500 people is, we just got to multiply 500 times 37 over 100, and that will give us the amount of people that are vanilla customers that day, and that would have been 185 customers.